Hi everyone, welcome to Practical Electronics. In this tutorial we're going to look at some basic circuits from what we have learned before. In previous videos we looked at fundamentals of electronics that covered components and their properties, component arrangement, the math of electronics. We also got to build our first circuits, which was a 5-volt DC power supply and an adjustable power supply of 1 to 16 volt DC, which used an AC source of 230 volts. In this tutorial we're going to make some basic circuits to help us understand some measurements. We will also make circuits to drive loads so we can understand the flow of current. In this lesson we're going to cover theory and recap of fundamentals, circuit components, circuit layout and design, measurements, and we'll take a look at some observations. Let's take a look at some theory. Electrical current flows from a point of higher potential to a point of low potential. Current chooses the path of least resistance. Resistors resist the flow of current in a circuit. Components can be arranged in series or in parallel to make a component of a different size. Diodes only allow electricity to flow in one direction. Current is measured by placing a multimeter in series with the branch of the circuit being measured. Voltage is measured by placing a multimeter across the branch of the component that's being measured. These are the components we're going to use in this video. We're going to use 1 kilo ohm resistors, an LED, and an electric motor. The tools we're going to use are a simple breadboard and a multimeter. So let's take a look at how we take measurements. For the first circuit, we're going to have two resistors in series. What we want to measure here is the current and the voltage across the second resistor. From the calculations that we have done before, using the method of electronics, we are able to calculate the total resistance. We are also able to calculate the total current that's flowing through the circuit. This we can verify through actual measurements with a multimeter. The expected voltage over the second resistor is 2.5 volts. This is a breadboard that we're going to use for building our circuit. On the breadboard, the connections are made across at the top and they go vertically in the middle, and they also go straight across at the bottom. And here is a built-in power supply. Over here we have our custom-made power supply, which we made as our first circuit. This takes a 9-volt input from the battery and converts it to a 5-volt output. So as you can see on the multimeter, that's our 5-volt output. The first circuit we're going to build is as shown. We're going to put two resistors of 1 kilo ohm resistance in series, and we want to measure the current and the voltage. And there we have placed our resistors in series. Right, so now we can take some measurements. As you can see, we still have our 5-volt input, and by measuring across the second resistor, we see that we have 2.48 volts, which is an equivalent of 2.5 volts. That's expected from the calculation. And over here we are measuring the current across the circuit, and we have 2.5 milliamps flowing through. For the second circuit, we're going to place two resistors in parallel, and we're going to take measurements across them. So we are still interested in the current across the circuit and the voltage across the two resistors. So following our calculations, the equivalent resistance will be half of each of the resistors, which is 500 ohms. And the total current through the circuit will be 10 milliamps. As for the voltage, it will be equal to the input voltage because we're still measuring across the same terminals. So let's build this circuit. We build the circuit by rearranging the resistors to be in parallel instead of in series like before. Here I'm just making sure that all the connections are made properly. We can now set the multimeter to voltage mode and measure the voltage. Over here an honest mistake has been made. I forgot to connect the negative lead of the multimeter to the circuit, and there I'm rectifying the mistake now. Then we'll start seeing our value. As expected, the input voltage is around 5 volts at 4.97. So measuring across each of the resistors will still give us the same voltage. Right, so let's adjust the multimeter to current mode and measure the current through the circuit. So from what we see here, we get 10.2 milliamps across the circuit, which is similar to what we got in our calculation. So now let's build some circuits that drive a load. For the first circuit, we're going to drive a load of an LED, meaning that we're going to illuminate the LED. In order for us to control the current flowing through, we have to put a resistor in series with the LED to limit the current, so as to not blow the LED. So let's build this circuit. This is the LED, and we can see the negative terminal clearly marked. We place the LED, then we place the resistor in series with the LED. So from this, we're going to measure the voltage across the LED, and we're also interested in the current through the whole circuit. So by making the connection, we can see that the LED lights up or it illuminates. We start by placing the multimeter in voltage mode and making sure that the negative LED is connected before we start measuring. So this is the total voltage across the circuit, and over here we get the voltage across the LED, meaning that the LED consumes 2.34 volts. And over here we're getting the voltage across the resistor. Right, and then now we can put the multimeter in current mode and measure the current flowing through the circuit. And here we get 2.4 milliamps flowing through our circuit, also flowing through the LED. The more current you drive through your LED, the brighter it will become. The last circuit we're going to build will be driving a motor as our load. And here we're interested in some measurements as well. Okay, we disassemble the LED circuit to now connect the motor. The motor requires quite a bit of current to drive, so this one will not work if you have a resistor in series. So by plugging the motor in, you can see that it's spinning in one direction, and if we reverse the polarity of the terminals, it then changes direction because the current is now flowing through the motor in a different direction. And as you can see, when we stop again, it changes direction once again. So here we are looking to measure the current that's flowing through this circuit, and we're going to compare it to our calculation. So here we're looking to measure the current that's flowing through the circuit. To do this, we place the multimeter in series with the motor, and once the connection is made, we're then able to see the current that's flowing. So we have about 160 milliamps that is flowing through the motor. Right now the current has increased to 190 milliamps or 0.19 amps. This time around we're going to do an additional calculation just to demonstrate the concept. We're going to use two resistors in series of different values. So the first resistor will be 1 kilo ohm and the second will be 2 kilo ohm. So the expectation here is that the 2 kilo ohm resistor will consume twice the voltage that's consumed by the 1 kilo ohm resistor, and we can verify that through our measurements. We first start by building the circuit by placing the two resistors. Then we adjust the multimeter to be in voltage mode and make sure that our negative lead is connected before taking the measurement. And what we see here is part of troubleshooting where the value is higher than what is expected and a mistake was noticed and rectified. So we verify the input voltage and then we measure between the two resistors. So what we can see is that the 2 kilo ohm resistor consumes more voltage, which is 3.33, and the rest of that voltage will then be used across the 1 kilo ohm resistor. Let's make some observations to conclude. A good understanding of the fundamentals is important for electronics design. Component characteristics can be used to manipulate the flow of voltage and current to give a desired output. Components can be arranged in series or in parallel to form an equivalent component of a different size. Known parameters can be used to calculate unknown parameters. A multimeter can be used to verify or determine measured values. Current, voltage and power are key parameters of quantifying electricity. Thank you and see you in the rest of the videos.